Okay, going to run through the rest of Chapter 5. I already went through pages 2 and 3, but the video got deleted accidentally, so I'm just going to show the answers for them. Well, once again, for 9, 10, and 11, when you cancel arc, cos, and cos, you have to make sure that you end up within the restricted domain. For 4 pi over 3, you do not for cosine, which is just the top, so you have to reflect it up to the same point up there, which gives you 2 pi over 3. For 10 and 11, those are both in the restricted domains, so you're all set. For page 3, here's the work. You're using law of cosines for most of it. There's number 12, 13 and 14, 15 and 16. And now I'm going to continue on with pages 4 and 5. Alright, page 4. Find sine of s. Well, sine is opposite over hypotenuse. So for s, opposite is 7, and hypotenuse is the square root of 65. Problem is, you cannot have a square root on the bottom, so you have to rationalize the denominator. If I have 7 divided by the square root of 65, I have to multiply by the square root of 65 divided by the square root of 65, giving me an answer of 7 square root of 65 over 65. Part B, I want tan of C. C's here. Tan is opposite over adjacent, so 4 over 7 is my answer there. C, I want the cosine of C. That's adjacent over hypotenuse, so 7 over the square root of 65. And once again, if I have 7 over the square root of 65, it's going to be the same as part A, 7 square root of 65 over 65. For D, find angle C. You can use anything you want. I like easy, no square root, so I'm just going to use tangent, opposite over adjacent. So I'm going to say tangent of C equals 4 over 7, and take the inverse tangent of 4/7, which is 29.7 degrees. I'm going to round to the nearest degree, which is 30 degrees. Number 18, we want to do the same exact thing. Tan of S. Opposite over adjacent, 9 over 7. Cosine of S is the adjacent over the hypotenuse, so that's going to be 7 over the square root of 130. Rationalize the denominator, you're going to get 7 square root of 130 over 130. And then the sine of C, which is opposite over hypotenuse, is going to get you the same exact thing, so 7 square root of 130 over 130. Angle C to the nearest degree. Again, I'm going to use tangent. I've got tangent of C equals 7 over 9, and I'm going to do inverse tan of 7 over 9 to get 37.9. Nearest degree, 38 degrees. Number 19 is the exact same thing. I'm just going to put the answers on here for you to see. First one, 3 square root of 34 over 34. B would be 5/3. C would be 3/5. And D would be 31 degrees. Ask me if you need help with any of those. I'd be happy to help. And then finally, for number 20, I want the inverse cosine of this. Well, for cosine, we can only consider the top of the unit circle. So where is the x value of the cosine? Negative square root of 3 over 2. The answer is right here. This is the point negative square root of 3 over 2, comma 1/2. So in radians, that's 5 pi over 6. Number 21, exact value of the inverse sine of this. Think about for the restricted domain of sine, which is the right-hand side of the circle. Where is the y value? Negative square root of 2 over 2. Right here in the middle of this quadrant, so the answer would be negative pi over 4. For number 22, the exact value of the inverse tan of square root of 3 in radians. Again, I'm going to do this the same way I did on page 2. Easiest way to do this, rather than having to worry about sine divided by cosine and figure out all that. Make sure you're in degree mode. Even though it wants to be in radians, put yourself in degree mode. Punch this into your calculator. Inverse tan of the square root of 3. It gives you 60 degrees. Well, you should know that 60 degrees in radians is pi over 3, and that's the shortcut. Finally, 23. You have a triangle x, y, z. Draw yourself a triangle. X, y, and z. X, that means side across from x, is 6.3. Y, that means the side across from y is 9.6. And angle z is 37. We want to find z. which is this side right here, z. Since the given information goes side, angle, side, this is a law of cosines problem. We're going to solve for z, so z squared is by itself. The other two sides, 9.6 squared plus 6.3 squared minus 2 times 9.6 times 6.3 times the cosine of the angle, which is 37. In my calculator, I'm going to do this all at once. Square root of 9.6 squared plus 6.3 squared minus 2 times 9.6 times 6.3 times the cosine of 37. You should get your angle, or your side, which is 5.9 to the nearest tenth, and you are all set.